Hi guys, so today I'll be explaining the chemistry AMS quiz of week 5. So consider the following equation: 3H2 plus N2 to give NH3. 3 moles of H2 are mixed with excess N2. When equilibrium is established, 1.5 moles of NH3 are produced. And we need to find the percentage yield. And the equation for percentage yield is actual yield over theoretical yield times 100. And the actual yield is always given, so 1.5 moles. And then theoretical yield, you need to find it using stoichiometry. So to do that, we're going to do 3 moles of H2 that the given gives question mark moles of NH3. This one, okay? And then under the moles of H2, we're going to write the coefficient of H2 in the equation, so 3. And then under the moles of NH3, we're going to write the coefficient of NH3 in the equation, so 2. Then we're going to cross multiply. We're going to get the theoretical yield to be equal to 2 moles. So now we're going to use the equation. So actual yield, which was 1.5, over theoretical yield, which was 2, times 100, we're going to get 75%. Which of the following electron configurations correspond to noble gases? Okay, so this is a new concept. And what you need to know is that we have a nucleus. In an atom, we have a nucleus which contains protons and neutrons, and then we have electrons around it. Okay? So basically like this, okay? But what we didn't know, there was separate layers of electrons holding different amounts of electrons. So like basically we have like 4 layers maximum, so 1, 2, 3, and then 4. Yeah, 1, 2, 3, 4, okay. And then the first layer can hold maximum of 2 electrons, second layer 8, third layer 8, fourth layer 2. Okay? And not all atoms have the same number of electrons, so it's gonna vary between atoms, okay? So using this, so in this case it would be 2882, okay? What can we know from this electron configuration? We know the last number is the valence electron, and then the first 3 numbers are the core electrons, and the last number is the number of the group that the atom is in, the element in the periodic table, and the number of layers, so in this case it would be 1, 2, 3, 4, is the period number. So in this case it'd be the period number would be 4, صح? P4. So group 2, period 4. So we can find it in the periodic table. In this case it would be group 1, group 2, and then period 4, so 1, 2, 3, 4. So it'd be SR. So now how can I know which electron configuration belongs to a noble gas? Again, noble gases are group 8, and we said that the last number in the electron configuration corresponds to the group number. So we just need to find an electron configuration that ends with 8. So not the first one, second one, not the third one, not the fourth one, the last one. Okay? Which of the following is the electron configuration of Na11? So Na and then 11. This is the number of electrons. And remember how I said the maximum number of electrons in each layer is like this? So 2882. First layer, second layer, third layer, fourth layer. Okay, so now we're gonna have to spread the number 11 between these layers, but in order. So I can't fill the first layer and then go to the third layer. No, wait, I can't fill. Yeah, you have to go in order. Okay, 1, 2, 3, and then 4. Okay, so let's fill the first layer. So 2, and then second layer 8. Now it's 10, and now I can only fill one more. 1. So here the total number is 11, صح? Which is equal to the electron number. فهيك we're done. So 281. So that's the first one. And here an aqueous solution of HCl is added to lumps of CaCO3. What is the expected observation? We know when CO3 reacts with an acid, it forms CO2. which is the gas, so there's going to be bubbles of gas. And then the products of the net ionic equation, we know when we have acid plus metal carbonate, it forms H2O and CO2, صح? So that's the answer. CO2 and H2O. Ammonia is produced industrially from N2 and H2 by a process called the Haber process. The conditions, okay, so temperature is 450 degrees Celsius and pressure is 200 atm or 20,000 kilopascals, and the catalyst is iron, and yeah, that's it. So 200 atm, yeah, okay. And then the catalyst is iron, and the catalyst increases the rate and has no effect on the yield of ammonia. Okay, room temperature and pressure is abbreviated as RTP. Standard values are 25 degrees Celsius and 1 atm. You need to memorize this. The first ionization energy is the minimum energy required to... Okay, I'm just going to write the answers. I'm just going to put the answers and then explain it, okay? So, again, the first ionization energy is the minimum energy required to remove the most loosely bound electron from a neutral gaseous atom. Okay, so let's say this is my atom. This is my nucleus. And then here's my electrons. So this is neutral, right? We have 3 protons, 3 electrons. And look, it's following the layer thing. Look, here we filled the 2 and then we went to the next layer. For the minimum energy required to remove the most loosely bound electron, يعني the furthest electron from the nucleus in a neutral atom, is called the first ionization energy. So the energy required to remove this electron is called the first ionization energy. Now you might ask, why don't I remove this one, like the one that's closer to the nucleus? It's harder to remove it. Why? Because it's closer to the plus, it's closer to the nucleus, so it's gonna be more like attached to the plus, لأنه صح they're attracted. Plus or minus attract each other, صح? Yeah, that's it. It's easier to remove the one that's further away. The empirical formula of a compound CH2, so CH2O. Wait, what? The empirical formula of the empirical formula of a compound is CH2O. The molar mass of the compound is 60 grams per mole. What is its molecular formula? Okay, so they gave us this formula, and they said, it's supposed to be, and this is the empirical formula, and the molecular formula is 60 grams per mole. That's its molar mass. How can I change this compound to make its molar mass equal to 60? So first we have to find its molar mass when it's like this, and then multiply the whole thing by a number to make its molar mass equal to 60. So when it's like this, its molar mass would be 12 plus 2 plus 16, so 30. And if I want to go from 30 to 60, we just multiply by 2, right? So we're just going to multiply this whole thing by 2. So C2H4O2. C2H4O2. A hydrocarbon is 75% carbon by mass. Find its empirical formula. Okay, so hydrocarbon is basically just a compound. It's just carbon and hydrogen, okay? It is 75% carbon by mass. يعني 75%, يعني 75 over 100 is carbon. يعني I have this 100, 75 of it is carbon and the rest is hydrogen. To find the rest, you just need to do 100 minus 75, you get 25. So 25 grams of hydrogen and 75 grams of carbon. Okay, now to find its empirical formula, we need to do some steps. First thing we need to do is find its moles. So we need to divide by its molar mass. So divide this by 12 and divide this by 1, we'd get 6.25, and here we'd get 25. Now second step is to divide by the smaller number. So here is 6.25 and here divide by 6.25. So here we'd get 1. and here we'd get 4. Now the numbers mean the number of each element we have in the empirical formula. C, we only have one C, so C1, we don't need to put the 1, and H4. Okay, so CH4. Okay, now this is the redox question. It's really easy. Just choose, you need to know which chemical equation is a redox reaction. It's basically just metal and oxygen to give metal oxide, or metal plus acid to give salt and hydrogen most of the time. Okay, so if you're not sure, just double check the oxidation numbers and make sure one element increases and the other element oxidation number decreases, because that's basically a redox reaction. So it's not the first one, not the second one, it's the third one and fourth one. Okay, so last two are redox, non-redox, and non-redox. Okay, here oxidation numbers. Oxidation number of oxygen is always -2, and nitrogen we need to find it. So X plus 2 times -2. X is for the nitrogen, which we're finding, and then I did 2 times -2 because the oxidation number of O is -2, and we have 2 oxygen, and it's equal to 0. So X minus 4 is equal to 0. X is 4, plus 4. So plus 4 and minus 2. And hydrogen is always plus 1, oxygen is always -2. We need to find the Cl. So 1 plus X plus 4 times -2. The 1's for the H, and then the X is for the Cl. And then I did 4 times -2 because we have 4 oxygens, and oxygen's oxidation number is -2. And that's equal to 0. So X minus 7 is equal to 0. X is equal to plus 7. Last one, oxygen is always -2 again, and then to find Mn we're gonna do X plus 4 times -2 is equal to -1. The X is for the Mn, and then I did 4 times -2 because we have 4 oxygens, and the oxygen's oxidation number is -2. And then I did it equal to -1 because that's its charge. So when we simplify, we get X minus 8 is equal to -1. We get X is equal to plus 7. So plus 7 and minus 2. Hydrogen reacts with carbon monoxide to produce ethanol, as shown in the following reaction. When 0.5 tons of hydrogen gas reacts completely with CO, the amount of methanol produced is 3 tons. Okay, so we're gonna have to find the theoretical yield and then percentage yield. Again, the theoretical yield is just stoichiometry. So to find the theoretical yield of methanol, we're gonna do 0.5 tons of hydrogen gives tons of methanol. And then under the tons of H2, we're just gonna write the molar mass of H2. So 2 times its coefficient, which is 2. And then under the tons of methanol, we're gonna write the molar mass of methanol, which is 32 times its coefficient, which is 1. Now we cross multiply, we're gonna get 4 tons, so that's the theoretical yield. Now to get the percentage yield, the equation was actual yield over theoretical yield times 100. And the theoretical yield was already given, I think it was 0.5. Then you divide that by 4 times 100, you're gonna get 75%. Okay? Wait, let me double check. It's 0.5. So it's 75%. Oh wait. Yeah, here it says 2 significant figures, so I just need to add a 0. A student wanted to find the maximum mass of Al2O3 produced when a sample of 0.8 moles of aluminium reacts with excess oxygen. The chemical equation of the reaction that takes place is presented below. So we just need to find the mass, okay? So let's look at our given. They told us that 0.8 moles of aluminium reacts with oxygen. So we're gonna do stoichiometry again. 0.8 moles of Al gives question mark grams of Al2O3. Under the moles of Al, we're gonna write the coefficient of Al in the equation, so 4. Then under the mass of Al2O3, we're gonna write the coefficient times the molar mass, so 102. That's the molar mass of Al2O3. So now we're gonna cross multiply, and when we do that, we're gonna get 40.777, I think, صح? And then then you're gonna round, so it's gonna be 40.8 because they want 3 significant figures. So 40.8. Now electrolysis. So multi-electrolysis of CaF2. Identify the element produced at the cathode and the anode. Okay, so whenever we see multi-electrolysis, you just need to write like on the side, cathode, reduction and metal, anode, oxidation and non-metal. Non-metal. So in this case, at the cathode we're gonna get Ca, and at the anode we're gonna get F2. So cathode Ca, anode F2. Now for the half reactions, at the negative electrode we have reduction, صح? And reduction, we have electrons in the reactants, so Ca2 plus 2 plus 2E minus to give Ca, and then at the positive electrode we had F2, and at the anode we have oxidation, so electrons are in the products, so F minus, sorry, to give F2 plus 1 electron, 2 electrons because we have 2 Fe, so 2 electrons. Okay, next here we have aqueous electrolysis. So first one, we have concentrated KBr, and when you have aqueous electrolysis, we're gonna do the questions. So let's start with the anode. Is the anode made of Cu or Ag? No, they didn't say that. So does the solution contain concentrated I, Br or Cl? Yes. So at the anode we're gonna get Br2. And the cathode, first question was, does the solution contain Cu or Ag? No. So the product at the cathode is H2. So Br and H2. Now for the second one, dilute NaCl, Na plus Cl minus. Let's start with the anode. Is the anode made of Cu or Ag? No. Does the solution contain concentrated Cl, Br or I? No. So at the anode we're gonna get oxygen. And at the cathode, first question was, does the solution contain Cu or Ag? No. So the product at the cathode is H2. So O2 and H2. Now last one, dilute solution of CuSO4. Let's start with the anode. Is the anode made of Cu or Ag? No. Does the solution contain concentrated Cl, Br or I? No. So the product at the anode is O2. And then at the cathode, does the solution contain Cu or Ag? Yes, so the product is Cu. So O2 and then Cu. 0.25 moles of CO react with what deciliter cubed of O2 at STP? Now it's really easy. The formula for this is like this. So N, V, RTP or STP. RTP is 24, STP is 22.4. And they give us the moles of CO. Now to get the moles of O2, we just need to divide this by 2, since the ratio is 2 to 1. You can just know this from the coefficients in the formula. So since it's 2 to 1, the number of moles of O2 is 0.25 divided by 2, which is 0.125. So O2's moles is 0.125, and we need to multiply that by 22.4 since it's at SCP, so times 22.4, we're gonna get 2.8. So 2.8. 2.8. Now next question. 1 mole of H2 reacts with 0.25 moles of O2 to produce H2O. Which reactants is in excess? Now this is diminishing reagent and excess. Yeah, okay. So first thing we need to do is find the moles which they gave us. So 1 mole of H2 and 0.25 moles of O2. Now we need to divide both numbers by their coefficients. So first one divided by 2, second one divided by 1. So 0.25 and then 0.5. This is H2 and this is O2. Now the smaller number is the limiting reagent. So O2 is limiting reagent. So since this is limiting reagent, the other number is the excess reagent. So H2 is the excess. Do I need to write the... Oh yeah, you need to write the 2, okay? 100 grams of hydrocarbon only contain 20 grams of hydrogen, 80 grams of carbon. What is the mole ratio of hydrogen atoms to carbon atoms? So same thing as the other question. H and then C. 80 grams of carbon, so 80 grams carbon and 20 grams of hydrogen. First thing we need to do is find the moles divided by the molar mass. So divide this by 1, divide this by 12. You're gonna get 20. And then the second one, you're gonna get 6.66666, okay? And now we have to divide by the smaller number. So 6.666 and then 6.6. Okay. So carbon is 1, hydrogen is 3. Okay? So H to C is 3. A sample of a compound contains 0.96 moles of hydrogen, 0.24 moles of carbon, and 0.48 moles of oxygen. The simplest formula of this compound is C. Okay. So same thing as the other questions, but here they gave us the moles. So hydrogen, carbon, oxygen, 0.96, 0.24, 0.48. They already gave us the moles, so we just need to divide by the smaller number. So divide all of them by 0.24. You're gonna get 4, 1, and then 2. So it's CH4O2. CH4O2. Sodium has an atomic number of 11. The electron configuration of sodium, again, Na11, 2882. This is the maximum number in each layer. So now we need to go in order and fill each layer one by one. So 2, 8, and then 1. This is 11, so we just need to write 2, 8, 1. 2, 8, 1. Refer to the electronic configuration in part 1. Choose the group and period to which sodium belongs. Again, the last number is the group number, so 1. Then the number of layers is the period number, so 3. The electronic configuration of carbon is 2, 8. Using the electronic configuration, fill in the blank with the correct number of valence electrons. The last number is the valence electrons and the group number, okay, so it's 4. Oxygen has an atomic number of 8. Choose the correct electronic configuration of oxygen. So again, 2, 8, 8, 2. This is the maximum number in each layer. And oxygen is 08, so 2 and then 6. 2, 6. Sodium has an atomic number of 11. Write the configuration, the electron configuration of sodium ion. Now there's a difference between Na and Na+. This is sodium and this is sodium ion. So both of them still have the 11, but since it has a plus, it's gonna lose an electron, right? So it's, instead of it being 2, 8, 1, we're gonna just remove the last electron from for this layer, so it's just gonna be 2, 8. 2, 8. Sulfur has an atomic number of 16. Write the electronic configuration of sulfide ion, so S2- 16. So first let's write the electronic configuration without the 2- and then add the 2- later. So it's gonna be 2, 8, 6. Now let's add the 2-. Since it's an electron, we add it, we don't subtract from this. So we're gonna add it to the last layer. It's gonna be 8. So 2, 8, 8. 2, 8, 8. Choose the ions that form a white precipitate upon addition of aqueous solution of potassium sulfate. When you add Ba and Ca to SO4, you get a white precipitate since they're insoluble in SO4. Choose the ion that forms white precipitate upon addition of aqueous NaCl. It's Ag, because AgNO3 and Cl, we're gonna get a white precipitate. And then same thing with Br, Ag. AgNO3 and Br gives a clean precipitate. Which of the given ions release a gas that turns lime water milky upon reacting with an acid? Carbonate. Yeah, because since carbonate, when it reacts with an acid, it releases CO2, which turns lime water milky. Which of the given ions releases a pungent smell that turns moist litmus paper blue? Red litmus paper blue upon acting with a base. Now here, since they didn't say aluminium powder, which is the catalyst for NO3, it's gonna be NH4. Let me say it properly. Both NH4 and NO3, when they react with NaOH and heat, both of them release NH3. But the main difference is that NO3, it needs a catalyst, which is aluminium powder. So if they don't say that they added aluminium powder, it's gonna be NH4. But here, since they said they added aluminium powder in part C, it's NO3, so nitrate. Then choking odor, sulfate. Sulfite. There's a difference between sulfate, which is SO4 2-, and sulfite, SO3 2-. This one, when you add it to Ba, we get a white precipitate. This one, when you add it to an acid, it releases SO2, which is a choking odor and decolorizes KMNO4. A student is asked to find the OH of hydrochloric acid whose pH is 5.36 at 25 degrees Celsius. Now, if you remember the equation, it was negative log of the concentration of H plus is equal to the pH. So here, since they give us the pH, it's negative log H plus is equal to 5.36. Now we multiply both sides by the negative, so log H plus is equal to negative 5.36, and then we do 10 to the power of this number, so negative 5.36. Now I lost my calculator, so I don't know the exact number, but I remember it started with like 4.36 times 10 to the power of negative 6, I think, something like that. Now we're gonna use the formula, the KW formula. So KW is equal to concentration of H plus times the concentration of OH minus. So 10 to the power of negative 14 is equal to this number, 4.36 times 10 to the power of negative 6 times the concentration of OH minus. Put that to the other side, you get 2.29 times 10 to the power of negative 9. Okay? 2.29 times 10 to the power of negative 9. And last question. Sulfuric acid is manufactured industrially. I don't read this, it's okay. Just look at this part. Chemical formula of A. Here, since it's contact posits sulfur, so SO2 plus O2 to give SO3. SO3. Conditions and temperature. Temperature is always 450 degrees Celsius in both contact and Haber process, but the pressure is 2 atm or 200 kilopascals. So this one. Last question, catalyst is V2O5 or vanadium pentoxide. Bismillah. Okay, thank you guys for watching. Good luck in your exam.